Okay, good morning to everybody. Today we will learn what is Taylor series, Lorentz series of a complex power series. Actually, there are two types of complex power series. One is Taylor series and other is Lorentz series. So first of all, what is complex power series? Actually, complex power series are the most important and fundamental series in complex analysis because the power series represents analytic function. So this power since the power series represents analytic function, so it is very important in complex analysis. Conversely, we can say every analytic function can be represented by a power series, namely Taylor series. So first of all, what is the power series of a complex function? A series of the form, a series of the form summation n equals to 0 to infinity n z minus a whole to the power n. This series can be written as, if we put n equals to 0, then we get what? A 0 plus, if we put n equals to 1, then we get a 1 z minus a. Then for n equals to 2, a 2 z minus 2. So z minus a. Z minus a whole square plus dot dot. Where z is a complex variable. Z is a complex variable. Uh, and all s are the complex constant. And a naught, a1, a2, dot dot, all and a are complex constant. Then it is called power series. Power series of a complex function. In powers of z minus a. Z minus a whole to the power n. This is why it will be in powers of z minus a, or a power series about the point a, or a power series about the point a. Here actually all the complex constant a naught, a1, a2, dot dot, this all are called coefficients of the series, right? Coefficient of the series. And is called center is called the center of the series. This A of the series is called the center of the series. Now, what will be the Taylor series? Number 2, Taylor series. So, what will be the Taylor series? If f of z is analytic, if f of z is analytic inside a circle C with center A and radius R. That means circle will be like this. Okay. Then at each point Z, then at each point Z, each point of Z inside the circle, inside the circle, then f of z can be written as f of z equals to f of a plus f dash a by factorial 1 plus this will be multiplied with z minus a plus f double differentiation at the point a divided by factorial 2 into z minus a whole square plus triple differentiation at point a factorial 3 into z minus a whole cube plus dot dot. Now n plus 1th term, what will be? F of nth derivative at point A of that analytic function and n factorial multiplied with z minus a whole to the power n plus dot dot. And this is infinite series, remember it. Which is called Taylor series. This is called actually Taylor series. Now, what will be the Lorentz series? what will be the Laurent series? Suppose there are two circles. Let C1 and C2 be concentric circles. Be concentric circle. That means center will be same with radius A, and sorry, with center A, and radii. Actually, radii means plural of radius. Radii will be R1, R2, R1, R2, where R1 is greater than R2. That means first radius of first circle is greater than R2. Suppose we have two circles like this. Center is A, and this radius is R1. Okay. Suppose this is the first radius, and this is the second one. So this is R1 and this is R2 radius. Same center. This is why concentric circle. Let f of z be analytic in the annular domain between the circles. Between the circles. Then at each point of the annular domain f of z, then at each point of the annular domain, mean f of z has the series of the form. The series will be like this: f of z equals to n equals to 0 to infinity, n equals to 0 to infinity, a n z minus a whole to the power n plus n equals to 1 to infinity b n z minus a whole to the power minus n, where R2 is absolute modulus of z minus a less than R1. This is the actually condition for the series. Where this a and can have the form 1 by twice pi I, 1 by twice pi I, contour integration on a circle C of W divided by Z minus W whole to the power n plus 1 dW. That means this is the actually Cauchy's integral formula, and here n equals to 0, 1, 2, etc. This is the coefficient n, and Bn coefficient, Bn here Bn coefficient will be same formula 1 by twice pi I contour integration on circle C f of W divided by Z minus W. Power will be, this power will be n plus 1, but this will be 1 minus n dW, where n equals to, n start with what? N equals to start with 1 to infinity. 1, 2, dot, dot, infinity. Then that means this series is called Laurent series, where the coefficient n equals to this 1 by twice pi and z minus a f of W divided by, this is the function at W, z equals to W, and this is the function at same W, but Bn coefficient can be represented by this. This is actually integral formula, Cauchy's integral formula for an analytic function. So ready is the actually plural of radius R1 and R2, where R1 is greater than R2, and the annular domain. Which will be the annular? Annular will be actually this part. This part is the annular part. So this domain is called also annular domain. F of z has the series of the form n equals to start with 0 to infinity and z minus I whole to the power n, and n equals to 1 to infinity bn z minus I whole to the power minus n. Remember, then this whole series of that analytic function is called Laurent series, where the coefficient n equals to this one. This is the actually Cauchy's integral formula. Okay, and this is also for the second part of the series, and this is the annular region, and first circle R1 and second circle R2. First circle radius R1 is the bigger and R2 is the smaller, and z minus a, that means this part, this shaded part lies between R2 and R1. That means modulus of z minus a, modulus of z minus a, what? There are many points, okay, z with the center A in this region. So z minus I will be what? The distance between every point of z from the center will lies between R1 and R2. R1 and R2. That means this, there are many points, Z1, Z2, Z3, Z4, Z5. So every point from the center A will be less than, will be greater than R2 and less than R1. That means annular domain. This is called annular domain. Now, example 1, first example of Taylor series. Find the Taylor series to represent the function z square minus 1 divided by z plus 2 into z plus 3 in the circle with less than 2. Modulus of z less than 2 means what? Circle with radius less than 2. Same words. So, first of all, considering solution will be, let f of z equals to z square minus 1 divided by z plus 2 z plus 3. This is the given function, and this is the actually rational function. Here are two zeros or singular points. The singular points, the singular points can be found with what? Z plus 2 into z plus 3 equals to 0. That means z equals to what? Minus 2 minus 3. And these two values are outside of the given circle, are outside of the given circle with radius less than 2. So f of z is analytic in the open disk, in the open disk of the absolute value of z less than 2 to about 0, about 0. And because center is what? 0. Now the given function can be written as z square minus divided by z plus 2 z plus 3. This is actually a rational function, so we can split this f of z into partial fraction. Okay, so this can be written as a partial fraction. Here we can write this can be written as a divided by z plus 2 plus b divided by z plus 3. So this can be written as z square minus 1 equals to a into what will be z plus 3. Sorry, this will be proper fraction 1 plus z plus 2 z plus 3 plus a into what will be z plus 3 plus b into what will be z plus 2. This is equation number 1 and this is equation number 2. So if z equals to minus 2, if z equals to minus 2, then if z equals to minus 2, then we get what? Minus 2 whole square means what? 4. 4 minus 1 equals to what will be? 3. So minus 2, for minus 2, this will become 0. And this also becomes 0. And this will be what? Minus 2 plus 3 what? Only 1. So a. That means a equals to 3. Clear? And if z equals to -3, then this will be also 0 and this will be also 0. So minus b, -3 whole square means what? 9. 9 minus 1 equals to 8 equals to minus b. That means b equals to what will be? Minus 8. So the series, the fraction from equation 1, we can write this fraction can be written as 1 plus a equals to what? 3. 3 divided by z plus 2 minus 8 divided by z plus 3. Now we are given the circle with radius less than 2. This implies if we divide by 2 on both sides, we can write less than 1. And z minus, if we divide by 3, then if we divide by 3, then it will become 2 by 3. Okay. And 2 by 3 is also less than 2. Less than 2 by 3. Less than 2 by 3. And 2 by 3 also less than what? 1. That means this 2 by 3 lies between this and 1. Therefore, the Taylor series f of z equals to 1 plus this 3 divided by z plus 1. We can write 3 divided by, if we take 2 common, then z by 2 plus 1. Okay. So 1 plus z by 2. Similarly, if we take 3 common, then 1 plus z by 3. After this line, can write this equals to 1 plus, we get 3 by 2, and 1 plus z by 2 to the power minus 1 plus, sorry, minus, this will be minus 8 by 3, 1 plus z by 3 whole to the power minus 1. So the series can be written as now like this: 3 by 2, 1 plus f whole to the 1 plus x whole to the power minus 1. What will be 1 plus x whole to the power minus 1? Formula what? 1 minus x plus x square minus x cube plus dot dot. Okay, just using this series from the binomial series. So x means what? Z by 2 here. So 1 minus z by 2 plus z square by 4 minus z cube by 9, sorry, z cube by 8 plus dot dot in this way, minus 8 by 3 1 minus same formula, same series, z by 3 plus z square by 9 minus dot dot. And this is the required Taylor series for the given function f of z, which is analytic. Now another example for the Laurent series. Find the Laurent series to represent the function in the region 1 less than absolute value modulus of z less than 2. Second one is 0 less than modulus of z minus 1 less than 2. That means circle with radius greater than 0 and less than 2. And third one is the circle with radius greater than 2. So we are the given function is what? 1 divided by z square minus thrice z plus 2. So this, it has two poles as the previous one. Now this function can be written as 1 divided by z minus 1 z minus 2. Okay, so there are two poles, one is or singularities, 1 and 2. Now we can write, let this 1 divided by z minus 1 z minus 2 can be written as a partial fraction plus b divided by z minus 2. So using partial fraction method, we can find this the equation number 1. So from this line, 1 equals to a into z minus 2 plus b into z minus 1. So if z equals to 1, then a b equals to 0. Okay, then b become, this term will be 0. So a z minus z 1 minus 2 means what? Minus a. Okay, so a equals to minus 1. Similarly, if z equals to 2, then this term will become 0. Then we get b equals to what? 1. Okay. Now f of z can be written as, from equation 1, can be written as minus 1 divided by z minus 1 plus 1 divided by z minus 2. This is the equation number 2. Now for the first part, circle, the circle between the radius 1 and 2. If 1 less than 2, that means if the circle with the radius between 1 and 2, then z lies in the annular region, in the annular region about z equals to 0. About z equals to 0. That means look like this. Suppose this is the with radius 0, sorry, with center 0, and another one is, so this will be 2 radius and this will be 1. That means annular region will be what? This one. Okay. That means every value of z will lies between 1 and 2. This is called annular region, which is about 0. 0 means what? Origin. And origin is the center here. So we have to expand uh, about z equals to 0, where f of z is analytic. First precondition is the function must be analytic. Now Lorentz series. Lorentz series. Lorentz series about z equals to 0. About z equals to 0 because the center is what? 0, 0. Now, absolute value of z less than 2. That means the circle with radius less than 2. This can be written as, if we divide it by with 2, because there are a term with z minus 2. So dividing by 2 on both sides, we can write less than 1. Okay. And another one is, you must know another condition, 1 less than absolute value of z. This is the given. Okay. The first condition is the circle or annular region 1 less than modulus of z, and this can be written as one by absolute value of z will be what? Less than or greater than? Less than 1. So the Lorentz series will be f of z equals to, f of z means equation number 2, and this equation number 2 can be written as minus 1 divided by z minus 1 plus 1 divided by z minus 2, and this can be written as 1 divided by z minus 1. If we take common z, we can take common z, 1 minus 1 by z, plus from the second one we can take common 2, 1 divided by, if we take 2 common, then it will become 1 minus 2 by z. Sorry, 1 minus, if we take common, 1 minus z by 2, and this become minus. So this can be written as minus 1 by z, 1 minus 1 by z whole to the power, what will be? Minus 1 minus half 1 minus z by 2 whole to the power minus 1. That means power with this a minus z whole to the power minus 1. Similarly, 1 minus a whole to the power minus b. Look like that. So you must know about this 1 plus x whole to the power, sorry, 1 minus x whole to the power minus 1 equals to what was? 1 plus x square plus dot dot. Okay, this is from binomial series. So just using this one here, we can find 1 by z, 1 plus 1 by z plus 1 by z square plus 1 by z cube dot dot. Similarly, for the second one, 1 minus x whole to the power minus 1, 1 plus z by 2 plus z square by 4 plus dot dot up to infinity. So after this line, we can write here this equals to, if you multiply with z, multiply with z, then it will become z to the power what? -1. And z to the power what will be? -2. And z to the power -3 plus dot dot minus half 1 plus z by 2 plus z square by 4 plus dot dot. This is the actually required Lorentz series for the annular one. Okay. So for the second one, 0 less than z minus 1 less than 2. Okay. Same function. If 0 less than z minus 1 less than 2, then z lies between the annular with what? About z equals to 1. And where f of z is analytic Lorentz series about z equals to 1. So we have to put here z minus 1 equals to t, then z equals to what will be 1 plus t. So for the t, for the converted region, t lies between 0 and 2. So this is then in this case, this whole region, whole disk become annular region between 0 and 2. This is the annular region, whole disk become annular region starting from center to radius 2. So t lies between 0 and 2. Now the Lorentz series will be what? For the second annular region, z equals to what? Z equals to 1 plus t, right? 1 plus t minus 1. This equals to 1 plus t minus 1. Then for the second one, this will be plus t plus 1 minus 2. So this series can be written as what? Minus, here 1 will be cancelled. So we can write only 1 by t. Okay. And for the second one, 1 divided by what will be? T minus 1. And this equals to minus t to the power minus 1 plus t minus 1 whole to the power minus 1. Right. Now we can expand using this series 1 minus x whole to the minus 1. This formula we can write minus t to the power minus 1 plus 1 plus what will be 1 plus t plus t square plus t cube plus dot dot the whole series. Okay. But in that case, it will become minus. So this series will be the actually Lorentz series. Now we have to put z values. T equals to what here? T equals to z minus 1. Now just putting t equals to z minus 1 minus z minus 1 whole to the power minus 1 minus 1 plus z minus 1 1 plus t equals to z minus 1 plus z minus 2 z minus 1 whole square plus dot dot since the absolute value modulus of t less than 2, And so in this series, t absolute value of t less than 1 is true. Okay, because we have taken t minus 1 to the power minus 1. Remember it, for this series we must satisfy this one. Okay, modulus of x will be less than 1. So this is true for our from our given condition. So similarly, we can find the third part. This will be homework for you. So this is the third part for the absolute value of z. Z greater than 2. Also, modulus of z greater than 2. That means the circle with radius greater than 2. Okay. So this region is annular about z equals to 0, where f of z is analytic. So the Lorentz series about z equals to 0 will be what? Modulus of z greater than 2. So dividing by 2 on both sides, we get z by 2. Modulus of z by 2 greater than 1. That means this imply if we divide on both sides, the inequality sign will be changed. Okay, dividing taking inverse on both sides. 2 divided by absolute value of 2 divided by z less than 1, and this is why multiplying dividing by 2 on both sides, we get 1 by z, absolute value of 1 by z less than half, dividing by 2 on both sides. And you must know this half must be less than 1. Okay, so the Lorentz series for the given function, analytic function f of z is this. Now just taking z common. Okay, then this become 1 minus x whole to the power minus 1 series, binomial series. Just putting the values, we get the required result. So similarly, this 4 example will be also homework for you. Okay, this 4. You have to find out the Lorentz series. Okay, thank you. Thank you to everybody.